Hello there, and thanks for tuning in to Beach Woodcraft. Today we're going to begin the journey of reviewing the CNC controller that I chose to replace my Spark Concepts controller. And we'll kind of go over the reasons why I chose it and why I think you might at least want to consider it if you're building a CNC machine or upgrading the control on your CNC machine. And this would apply to plasma machines or CNC routers or other types of machinery that you might control, like a mill or an automated mill or an automated lathe. So any of these devices can be controlled with this controller, and you should give it a good look if you're thinking about this type of a project. So to begin with, the gentleman who designed this control is a gentleman by the name of Bart Dring, and he is also the principal designer, programmer for the project FluidNC, which you may have heard of, and makes use of the ESP32 chipset that you'll find on many hobby level CNC control boards by many different manufacturers. So a lot of folks are riding on Bart's coattails, and I think he needs to, a high five from a lot of us who are interested in controlling a CNC machine for our hobbies, or maybe even a small business venture, if that's your goal. So here's Bart's CNC controller that I chose. He calls it the 6-pack universal controller. And as you can see, it's extremely affordable and very modular, flexible and modular. So there are 5 spaces for optional modules that can be installed on this controller, and there are 6 axes spaces for either internally populated or external drivers for your axes, X, Y, Z, and etc. So if we scroll down a little bit here, you'll see some pictures of the modules that can be populated onto this board, and the prices that go along with them. Extremely affordable. Here's a 10 amp relay. Here is a 5-volt output module, $12. Here are the input modules for digital inputs like limit switches and things like that, your probe, your e-stop, a 0 to 10 volt spindle control output. If your spindle needs a 0 to 10 volt signal to change its speed, you would use that. I use an RS-485 module for my spindle because they communicate over Modbus RS-485 protocol. So, and here are all the links for all these modules, and what you'll find in the link, let's just take a look at one such as, we'll look at this input module. This is 4 inputs on one module. So if we follow the documentation link, you will see how the pins are set up on this module. Signal, neutral, and a 5-volt supply for any of your switches that may need to be powered, like a proximity switch or some of these other switches that may need some power to power them up so that they can work. Scroll down, we will find this picture, which shows you which switch number or how they're numbered on the board. And you can see where it kind of says terminal block 4 here, terminal block 3 here, but it's pretty small, and if your eyes are, kind of older like mine, this is nice to have. So scrolling down a little bit further, you can see a simple end switch, such as I have on my machine, only uses the signal pin and the neutral pin. It doesn't need power. Scrolling down a little further, for the 6-pack baseboard that he sells, or main board that he sells, here are the pin designations for socket 1. So if you were to put this input module in socket 1, these are the pins that get assigned to that. So the switch that would get wired to the number 1 input is going to use this pin number, GPIO 33, and number 2 would use 32, and number 3 would use 35, and on. So if you were to put that in socket 2, these are the pin assignments. Socket 3, these are the pin assignments. So this is the sort of stuff that you need to go through as you're building your config file. Make the choices of which modules you're going to put in which socket, and then find out which pins are associated with that socket, and make sure that when you set up your config file, you use the correct pin numbers, or otherwise you'll get some unusual results. And the good thing about that is that as the controller loads the config file, it does a really good job of giving you error messages that mean something, so that you can sort of see where in the config file this error occurred, what section, and it'll give you as much information as it can about what might be wrong, whether the pin has been used in 2 different places, the pin number, or you have a grammatical error, or not a grammatical, but a spelling error, or any kind of thing that it doesn't recognize. It will kind of give you some feedback. So, and if you look down here, socket 5 is an output-only socket, so you cannot put an input module in socket 5. So, as you're reviewing all this information that's on the wikis all over the place, you kind of have to make decisions about which module you're going to put in which socket, and which modules can't go in at least socket 5, which is a little bit different than the rest. Has to be an output. And I used the relay. I used the relay module as one of the modules that I wanted to have, and so I put that in socket 5, since a relay is an output, and that gave me more flexibility for devices that I might put in the other sockets. The other thing of note is that if you use either this MOSFET module or the 5-volt output module, if you put it in socket 5, which it can go there, socket 5 is not capable of doing pulse width modulation. So if you have a PWM spindle, or if you have a laser, and most of the lasers that I've seen use PWM to modulate the power, you do not want to put, and either one of these can run a laser, you do not want to put that in socket 5, because I initially had that in socket 5 until I realized that socket 5 can't do PWM. So you'll find that when you're reading, reading through everything, and I'll have links in the information below to a lot of different wiki pages that will help you find all the information that you're going to need. And a good place to begin is here, which is the FluidNC Wiki, and it will take you through from the overview and all the things that you need to know about building your configuration file. And it kind of explains each section, and how that section, like for instance the inputs, how that section should be laid out. And we'll take a look down here. And so the inputs are under what's called they label that section control. So what goes there? Your safety door pin, your reset pin, your feed hold pin, your cycle start pin. And you don't have to use all these. If you're not going to use that feature, I believe you could just not even put it in the config file, but I believe their preference is for you to just put no pin. So for instance, most of us implement an e-stop. I chose to put the e-stop on the safety door pin instead, because this way I can restart the machine after an e-stop press. If you put it here, your job's done. You cannot restart the job. You're going to have to start over. And that isn't always easy. So, you may want to think about what you put where. The other thing that I found helpful was, let's see, we'll just take a look at a couple other things real quickly here. So user outputs. And I'll show you on the board why I found this helpful. So here's user outputs. And, if you're using, say, a 0 to 10 volt, if you're using a 0 to 10 volt spindle control, you may want to say analog output 0 is on whatever pin that is associated with the correct module that you have. So those are the sort of things that you need to figure out as you're building your config file. I put my relay on digital output 1 and assign the correct GPIO pin number to digital 1. So that's how I did my relay. So a couple other things to look at is the motor axes and the homing section of the config file, which is here. And I really encourage you to read over most, if not all, of these sections, at least the ones that apply to you. In other words, you're going to have motors, so you're going to want to read this section and read more carefully the sections that apply to you. In other words, whatever kind of motor drivers you're going to use, pay closer attention to that. And it sort of explains all these settings that are in the config file and how and why you might choose what you choose. And don't worry, this is really, it's not super complex, but there's a lot to it. So in a minute here, I'm going to show you the example configuration files. And they're fairly complete. So the good news is that you don't have to write this all from scratch. The best thing to do is start with the example that's closest to your machine's configuration, and then add and or remove the pieces that you that you need or don't need to that example, and fine-tune it, and you'll be done and save a lot of time. And also, I mean, in the end, we want to run our machine. We don't want to learn, unless, and if you do, you should, but I personally didn't want to learn, the every in and out of all of this. I just wanted to learn enough to get it configured and set up, and maybe come back and do some fine-tuning later. So you can read through here, and it'll show you if you're going to use external stepper motor drivers, you know, how you would set that up. Step stick type drivers. If you are going to use internal ones, then how you would set that up. In other words, the drivers that I chose are trinamic drivers. So, you know, I paid closer attention to this section. And in fact, mine are the TMC 5160s from Big Tree Tech. And I'll put a link in there if you're interested in those. And why I chose them is because they can output higher amperage. So if I ever did want to put larger stepper motors on my machine to move it a little faster or to have a little more torque, I can bump up the amperage in the config file, and I can run bigger motors. I also thought it was pretty neat to just have them integrated. The external drivers just take up so much room, your control cabinet's going to be bigger. So, and the nice thing about it here is I can run down in this file. I can find the section for the 5160s. This is, you know, 2130 here still. And you'll go through here and you'll just read, you know, read how this all works. And set up your config file. See, here's the 5160s. And it'll go through and it'll explain every setting in this file and what it means, and you know how you might set it up and choose what you want. But go through here, read everything that you need to read, and like for instance, we all have spindles if you're running a CNC machine, and we all have a probe more than likely. And if you don't, you probably should. They're not very expensive. You can even make your own. And this just will show you that the probe section of the config file is, strangely enough, named probe. So go through this, read all of it if you're up to it, or at least as much of it as you feel you need to get your configuration done. Now, the other thing that you're going to want to do, if you buy, especially if you buy one of Bart's boards or another manufacturer's board that isn't pre-programmed. He says here that he pre-programs them, but mine didn't come programmed, so it's really not a big deal. We come down here and we go to the FluidNC firmware. So open this link, and this is the GitHub repository for FluidNC, and as you can see, Bart Dring owns this, so he really is the man. He really is. Go to this code button here and select download a zip file, and that'll download all of these things for you. And I'm not sure what I just clicked on. Let me go back. And it'll give you the, you'll be able to easily install the firmware. It's super easy, and I'll put a link to one of Bart Dring's videos that kind of describes installing the firmware and doing some configuration setup. He doesn't go through it all, but he goes through a little bit of it, and that'll help you some as well. And then there are example config files that you can use, but and as you can see right here, the config files have been moved to their own GitHub repo. So click here, and I use the official, and you can download them all, or you can just download the one that's closest to your machine. In other words, or closest to your machine and the control board that you're using. So 6-pack with a solenoid valve, 6-pack using step stick controllers, X, Y, Z, A, B, C. And so Let me take you down through here and I'll show you which one I chose because it was the closest to my machine. So I use the 6-pack, and I have the TMC 5160s, and I have XYYZ, but I also have the Hung Yang. So I'm looking for one that is the most complete possible for my machine. And so I believe I chose this one. So this one is the 6-pack with the TMC 5160s, and it should be XYYZ, but here it says XYZ on the name, not sure why. But I started with this config file, and you can see if you look through axes X and the settings, the homing, and motor 0, using the 5160 driver, and the amperage settings I had to change for my machine. But go down through here, motors, XYZ, I2SO is the expansion. It uses these pins to give you the I2SO expansion pins. And they're sort of like, think about it as sort of like virtual pins. So here's the control section we talked about a little bit earlier. So I assigned a pin number to the safety door, which is wired to my e-stop. And here's the probe. You're going to want to assign a pin to that. If you want to develop macros, you can do those here. And then here's the output section. I assigned a pin to digital output 0 to turn my relay on. And then here's pulse width modulation, which I assigned to my laser. So I'm going to show you my config file real quickly so we can kind of look through it and get an understanding of how I set mine up. And then we will go and do some bench testing on the on my control, which is right here beside me on the bench, and how I checked mine to make sure that it was doing what I hoped it was doing. So there's the axes, and I'm only going to show you the parts that I changed because everything else I left the same. So I did set flood and coolant to these two pins, and then I did set safety door to where I intend to wire my e-stop, and then the probe to where I intend to wire the probe. I'm not currently using macros, but I hope to learn how to do that in the near future. And then here is my digital output that turns on the relay. And then here is my Hung Yang VFD, and that uses a UART, which is the RS-485 module, and these are the pins for the I/O module 3, which is where my RS-485 module was installed into the main board. And then the speed map, I updated a little bit because I want to be able to run my spindle as slow as 1200 RPM such that I can eventually put an automatic tool changer on there, and I intend to use the one that is designed by, I'll get back to you on that because I'm drawing a blank. But so my Hung Yang spindle uses tool number 0, and it'll use 0 through 9. So that'll, and 0 through 9 will have different bits assigned to them so that it can do an automatic tool change. And then my laser is tool number 10, and the speed map for that and the I/O pins for that. So this is the file that actually works for me. And this is a YAML YAML file, and I named it. I kept the name that Bart assigned to it, even though I had modified it a bit. So there's my file. We'll come back in a couple of minutes, and we'll go through the board layout and how I tested it, and then that'll be the end of this video. And the next video will be installing it on the machine and putting it through its paces on the machine. Okay, so the next thing that we're going to do is we're going to take a look at the Bart's 6-pack control board and go through some benchtop testing that I did to make sure that my config file was working the way I assumed it was, and show you how to the files that you download, how they work and where they are, and then we'll wrap this up. So if you recall earlier, I said we would download these files from the GitHub page. So you'll download, you'll get this FluidNC with the most current version, which I assume this is still the most current version. And it'll come in as a zip file. You'll extract it. And when you go in here, you will find batch files to install the Wi-Fi version of the firmware, a Bluetooth version of the firmware. I'm not really sure what this FS version is, but I'm guessing that most people are going to want the Wi-Fi version. And what that does is it creates a Wi-Fi access point on the control board that you can connect to, and then configure your own local Wi-Fi, or you can leave it in that way if you so choose, but you are able to run the machine via the built-in web server and upload configuration files and so forth. So you'll install that, and I'll leave a link to one of Bart's videos where he goes into good detail about installing it. It's very, very, very simple, and he also shows some manipulations of the configuration file, which will probably be helpful. So you should watch that video, and there'll be a link for it. The other thing that you get when you download under this FluidNC main is you get this terminal. There's a terminal server running on the board as well, and you can connect to it. And when you connect to it, sorry, I'm still connected with my G-code sender. You can't connect over the same USB cable with two different programs at the same time. So now we're connected. If I hit enter, we get an OK. Well, we should have gotten an OK. So I've just reset the controller, and you can see all these messages that we received back as it boots up, and they're all green. If any of them were red, it would say error, and it would be red, and it would tell you as much information as it's able to about the error. And it does a darn good job. So you can see here it tried to connect to my Wi-Fi, which is really poor down here in the garage. It also is trying to connect to the VFD over the RS-485 wires, and of course the VFD isn't over here on the bench, so it can't connect to that. But everything else is green and we're looking good. So what I'm going to do now is disconnect from this, and we'll take you over and take a look at the control board, and then we'll do some bench testing with the control board. But first, let me bring up my G-code sender, which I use. This is a free software that Open Builds provides, and a couple reasons I use it. One of the great wizards, I think, on here is this surface flattening wizard, where you put in the dimensions of the board you want to flatten, or the panel that you want to flatten, and how much you want to take off, and it writes the G-code for you. It's really great. The other thing that's on here that is really helpful is there is a I thought it was a wizard. Well, I'll have to find it for you, but there's a way to kind of frame it's. If you ever have done any laser engraving, a lot of the softwares have a feature called framing, where it'll basically like outline the area where it intends to laser, and you can adjust your piece until you get it in the right spot. Because a lot of lasers don't have true XY coordinates. They just are machine coordinates. They just have job coordinates. So you kind of got to just zero in that job coordinate manually. Anyway, we'll find that a little bit later. But let's go over here. This troubleshooting tab has some indications of when you hit your limits, X, Y, and Z limits. It also has an indication when you probe, and for me, the door sensor is my E-stop. If you recall, I want to use that so that I can resume the job. If I hit the E-stop in a panic, or I bump it by accident, I can start the job back up. So we're going to go over here to the to Bart's board, and I'll explain what's going on over here. Module 1, 2, 3, 4, 5. 4 inputs on module 1, 4 inputs on module 2. RS-485 output to the VFD on module 3. 4 outputs with the 5-volt output module in module location 4, and then the 10 amp relay in module location 5. And that matters because the pin numbers are different. So when you're building or correcting or adjusting your config file for your particular controller, you will make sure that the pin numbers for this module location match that portion of the config file. Then over here on this side of the board, we have our X, Y, 0, Y1, and Z stepper motor drivers. And I chose to purchase these TMC 5160 drivers from Big Tree Tech. There's the part number if that's something you might be interested in. They come in this nice little box. You can use this to help make sure you get it in the right way, and that's what they look like when they come out of the package. So I bought an extra one that I don't need yet, but if I add a feature, I have another one. So what we're going to do is we are going to simulate hitting a limit switch. So if I hit this Y limit switch, That did not work. Don't know why. Let me, oh, the reason why is because we're not connected. Okay. So, okay. So we are going to hit the Y limit switch, and as you can see, it triggers an alarm, and Y limit switch is hit. Now we'll do the X, and we'll do the other Y, which it can't differentiate between, but at least you know that it works. And here's the Z limit switch, and those are all tested. Now we'll test the probe. Probe is good. And now we'll test the e-stop or the door sensor, and that's good. And we'll unlock the control. Now the next thing that we'll do is we will test the outputs. And for that we have to type in commands to test the outputs. And so the first thing we're going to do is we are going to switch from spindle mode to laser mode, and you'll see how much easier it is to do with FluidNC. So the command is M6 and then T for tool, and our laser is tool number 10. So we click the button, and as you can see it says changed to spindle:laser. Then if we want to, if you look here, this is the mist, the flood coolant, and the laser outputs on this output module. So if I wanted to turn the laser on, M3, speed of 500, which is half power for the laser, light number 3 is on. M5 turns the tool off, it's off. We're going to do M7, turns on the mist, M8, turns on the flood coolant, M9, turns them both off. Now, if you recall, we set up the relay as a digital output 0. So we'll issue a command of M62 pin 0, and the relay's on. M63 pin 0, relay's off. And of course now these commands can be in your G code, so you can turn things on and off, you can receive inputs, and you can change, your G code can change, power down the routing spindle and power up the laser spindle during the same job to do interesting things if that's something you would like to do. So the next step after this is to install and wire this board in the control cabinet and go through some testing stepper motors, testing all the real limits, and making maybe some fine tuning and fine adjustments, and moving on with this new control. Last thing I'll say is the Barts circuit board does not come with this 3D printed sort of housing that I made. It's not a fully enclosed container. I was going to make a fully enclosed one initially, but I thought, there's just no need to. So if you would like the STL file to print your own, leave a like and a comment that you would like the STL file, and I'll send it to you. If you would like the step file to modify your own, subscribe to the channel, leave a comment that you would like the step file, and I'll send it to you. If you don't have a printer, a 3D printer and you would like me to make you one of these and send it to you, leave me a comment and we'll work something out. Again, I'm John. This is Beechwood Craft. Thanks for tuning in, and look for the next video testing this device on the machine. Have a great day.